Hello dear physics students. A student of mine has asked this question. A coil of insulated copper wire is connected to a galvanometer. What will happen if number 1 a bar magnet is pushed into the coil, second withdrawn from the coil, and third held stationary inside the coil. Let's just explore the solution of this problem. I am drawing a galvanometer here, and this is my galvanometer. This is how it will look like. I'm making the scale of galvanometer. Okay, let us say this is the 0 of galvanometer, and then we are having terminals of galvanometer. Let us say this is the positive terminal, and let us say this is the negative terminal, and then we are having our coil. So we are having our coil here, and one end of the coil is connected to negative and one end of the coil is connected to positive. Now there is a bar magnet, so let us consider a bar magnet is here. Let us say this is south pole and this is north pole. Okay, and the coil is such that if north pole is approaching towards this coil, then according to the orientation of coil, this face of coil will also become north. This is Lenz's law, and class 12 students can easily understand that, but for class 10 student who can remember this thing only, if north pole will approach a coil, the face which is facing the magnet will also become north pole, and for making it north pole, the current will flow in anti-clockwise manner. For making current flow in anti-clockwise manner, current will flow like this, and as current is flowing like this, so current is coming down from here and continuing this sequence. Here current is downward and here current is upward, so here is current is upward. So this galvanometer needle, let us say this needle which initially is at 0, this needle will give deflection, because current is as per opposite polarity. Current is entering from the negative terminal and leaving from the positive, so this needle will give deflection towards left. If it would have been south pole, the needle must have given deflection to the right, or if the polarity of the coil is interchanged, or if the direction of turns is changed. The only point about galvanometer is if you will connect it, the positive of galvanometer, to a positive supply and negative to negative terminal, then the needle is always gives direction in positive direction and vice versa. Okay, so next, what will happen if we will move the magnet, if we keep the magnet inside? First we are moving the magnet towards the coil. So when magnet is moving towards the coil, when it is in motion, it is moving towards the coil, this is the deflection which will take place. And in the same manner, if I'll draw the same arrangement again, let me draw the arrangement for you. So here you have seen as north pole is approaching the coil, its face which is facing the magnet will become north. In the same manner, if the north pole is receding away, then the side of coil which is facing the magnet will become south pole. And for making it south pole, current must flow in clockwise direction, and current will flow in clockwise direction like this. And for doing this, the direction of current induced in the coil will reverse, and your galvanometer which gave earlier deflection to the left hand side now will give deflection to the right hand side. Galvanometer coil will give deflection to the right hand side. So you can also solve the question with the same logic, because the pole is not specified and orientation of coil is not given. If any pole of coil is coming toward magnet, and needle of galvanometer will deflect in any direction, and if you will pull away the magnet, the needle will deflect in other direction. While in third case, when your magnet is kept stationary inside, there is no rate of change of field, there is no relative motion between coil and magnet, and no EMF will be generated, and the no deflection will be there. The needle will not deflect when magnet is kept inside the coil and is not moving. Galvanometer will not show any deflection. I hope you enjoyed it. Please like and subscribe and share and ask your questions in comments. This is Ashish Sharma, your physics partner. Thank you.